So this is the 2025 Ordinary Level Maths Paper 1. This is question 1 and this is the deferred paper. So let's have a look at question 1. We have to solve the equation where x is real. So we are starting with 4 times x minus 2 plus 10 is equal to 3x. So the first thing we're going to do here is multiply out the brackets. So that would be 4 times x. And then 4 times minus 2, which is minus 8. Add 10, and that's equal to 3x. Next line then, I'm just going to add these two here. So that's 4x. We've got minus 8 plus 10. So you go down 8, you go up 10. So you're up 2, and that's equal to 3x. So the next thing I'm going to do is I'm going to subtract 3x from both sides. I'm going to take this 3x and I'm going to bring it over here, in other words. So if I subtract 3x from the left hand side, I'll have 4x minus 3x. That'll give me 1x. If I subtract 3x from the right hand side, I'll get 0. Next thing I'm going to do is I'm going to subtract 2 from both sides. So plus 2 minus 2 will just give me 0. So that just leaves me with x. And if I subtract 2 from the right hand side, I'll end up with minus 2. So my answer is x is equal to minus 2. Okay, let's have a look at part B. Solve the following equation in x. So this is a quadratic trinomial. It says give your answer to 2 decimal places. So this should indicate that you need to use the minus b formula or the quadratic formula. So first thing you should do is write down what a, b and c are. So we can see that a is the coefficient of the x squared, which is 2. b is the coefficient of the x, which is minus 4. And c is the remaining number there without x, and that's minus 13. So your formula then is in your tables. It's x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So all you've got to do is substitute in the numbers for the letters. So it's minus b, well b was minus 4, plus or minus the square root of b squared, well that's just minus 4 squared, minus 4 times a times c. So a was 2 and c is minus 13. So underneath then it's just twice a, and a is 2. So all we've got to do is work all of this out. So here we have minus 4, so that's 4, plus or minus. Now you've got to do the square root of minus 4 squared. Well, minus 4 times minus 4, minus minus is plus, 4 times 4, 16. Here we've got a minus times a plus times a minus. Well, minus times plus is just minus, and then that minus times this minus is plus. So 2 4s are 8, and 8 times 13 is 104. So after that we divide that by 4. So let's see, what have we got? We have 4 plus or minus the square root of 120 over 4. So we have two answers here. We have to give our answer to 2 decimal places. So our x then, I'll have to come down here, x is going to be equal to, let's see, if we say 4 plus square root of 120 over 4, just do that on your calculator, you'll get 3.7386 and so on. Or if you do 4 minus the square root of 120 over 4, you'll get minus 1.7386 and so on. We've got to give these to 2 decimal places actually, so it's going to be 3.74 here. You've got to stop here. The number after the 3 is an 8, so we've got to round up. Or we've also got x is equal to 2 decimal places, we stop here. The number after the 3 is an 8. It's a 5, 6, 7, 8 or 9. So we've got to round the 3 up. So our answer is minus 1.74. Okay, so that's it for B. Let's have a look at C. Expressed as a single fraction. So we have 3x minus 1 over 2 minus 2x plus 2 over 5. So what you would do here is just draw a line and work out what a common denominator is, what a lowest common multiple of 5 and 2 is. So in other words, what number can we divide 2 and 5 into? Well, the lowest number we can divide 2 and 5 into would be 10. So then what you do is you say to yourself, well, what do I do to 2 to turn it into 10? Well, I need to multiply it by 5. So that means you just multiply the top by 5. So it's going to be 5 times 3x minus 1. Then you say to yourself, right, make sure you write this minus down here. And then you say to yourself, what do I do to that 5 to turn it into 10? Well, I double it. So double the top as well, 2x plus 2. So you'd be expected to simplify this then. It says in its simplest form. So multiply 5 by 3x, that's 15x. Multiply 5 by minus 1. Well, plus times minus is minus. 5 times 1, 5. Multiply these two. Minus times plus minus. 2 2's 4x. Minus times plus minus. 2 2's 4. And then we have 10 on the bottom. So let's just simplify this. So you need to add the x's to the x's and the numbers to the numbers. So we have 15x minus 4x. So you go up 15, you go down 4. So that leaves you with 11x. We have minus 5 minus 4. So you go down 5, then you go down another 4. So you're down 9. And then we divide that by 10. And that is it for question 1. Okay, let's have a look at the next question then. This is question 2. This is a complex number type question. So we have I squared is minus 1. We're given z1, which is 4 plus 3i. We're given z2, which is 2 minus I. They're two complex numbers. So we've got to plot and label the two complex numbers z1 and z2 on the argon diagram below. So the first one is 4 plus 3i. So we've got to come out 4, go up 3. So we would plot it here. Label it z1. So that's 4 plus 3i. Now the second one is 2 minus I. So it is over here. We've got to come out along here, 2 and then minus 1. So it's going to be here. This is z2. So that's 2 minus 1i if you like. So that's part 1. Part 2 then, the complex number w is shown on the argon diagram. Write w in the form p plus qi. So if we look at w here, we come out along the real axis first, so it's minus 3. Then we go down along the imaginary axis, so it's minus 2. So it's minus 3 minus 2i. Okay, next question then. We've got to write z3 in the form a plus bi. So z3 is z1 minus 3z2. So we've got z3, and then we've got that equal to z1 minus 3 times z2. So if we stick in z1 and z2 into this equation then, z1 is 4 plus 3i, given that in the question, and then minus 3 times z2, well, we're given z2 as well as 2 minus I. So you just got to multiply this out. So it's 4 plus 3i minus 3 times minus 2 is minus 6, and then minus times minus is plus. So it is plus 3i. Next one then, just add the numbers. So we got 4 minus 6, so go up 4, go down 6, so you're down 2. 3i plus 3i is 6i. And that is it, minus 2 plus 6i. Next question then, we've got z4. z4 is equal to z1 divided by z2. Well, that's just going to be equal to z1, which is 4 plus 3i. And then we got to divide that by z2, which was 2 minus I. Now the procedure here is to multiply by 1. And the version of 1 that we're going to use is the conjugate of this number here divided by itself. So it's 2 plus I divided by 2 plus I. So in other words, if you divide anything by itself, which we've done here, top divided by the bottom, you'll get 1. So all we're doing is multiplying this fraction here by 1, which doesn't change it. It'll change the way it looks, but it doesn't actually change the fraction. So why do we do that? Because it will get rid of the i's here on the bottom. Let's see how it works anyway. We've got to multiply 4 by 2, so 2 4 is 8. Then we multiply 4 by I, so that's plus 4i. We multiply plus 3i by 2, so that's plus 6i. And then we multiply plus 3i by plus I, so that's plus 3i squared. On the bottom then we do the same thing again. So we multiply 2 by 2, which will give us 4. Multiply 2 by plus I, so that's plus 2i. multiply minus I by 2, so that's minus 2I, and you can see these two here are going to cancel each other out, give us 0. And then here we got to multiply minus I by plus I, so minus times plus is minus, I times I squared. Okay, so let's just sort all this out. On the top we've got 8 anyway, we've got 4I plus 6I, so that's plus 10I. And then we have 3I squared. Well, I squared, we were told at the very beginning, is minus 1. So we're multiplying plus 3 by minus 1, so that's just minus 3. And then on the bottom, we've got these two here, which will give us 0. We got plus 2I minus 2I. So we have 4. And then we have an I squared here. Well, I squared again is just minus 1. So we got minus 1. So that's plus 1. Okay, last bit then, or second last bit I should say. So we've got 8 minus 3, which is 5, plus 10I. And then on the bottom we've got 5. So when you have a plus in the middle here, you must divide this 5 into both of these. If it was multiplied, if that was multiplied, you would just divide into 1. But because there's a plus here, you must divide into both of these. So 5 into 5 is 1. 5 into 10 is 2I. And that is it for question 2. Okay, next question then. Question 3, we have a function. It is x squared minus x minus 2. We just got to find f5 and f of minus 3. So f of 5 then is just going to be, you take out the x's, you put in the 5. So it's going to be 5 in brackets squared minus again in brackets 5 minus 2. So when you do that, you get 5 squared, which is 25 minus 5 minus 2. So that's 18. Okay, if we do f of minus 3, you do the same thing again. Just take out the letters, put in brackets and put in minus 3 in the brackets. So it is minus 3 squared minus 3 and then minus 2. So minus 3 squared minus minus is plus, 3 3 is 9. Minus minus here is plus 3 and then we got minus 2. So that will just give us 10. So that's part 1 done. Part 2, let's see, find the coordinates of the points where f of x crosses the x-axis. That is where f of x is equal to 0. So on the x-axis, y is equal to 0. And remember, our function is f of x is equal to x squared minus x minus 2. We are told that f of x is equal to 0, so this is 0 here. So you just put 0 there, is equal to x squared minus x minus 2. So we just got to solve this. So we're going to factorize it first. So take the x squared, well that's just going to be x times x. Take the 2, well there's only one possibility, 2 times 1. Now you got to think about it, you've got to get minus 2 when you multiply these two here. So to get a minus, the two signs have to be different. So we need a plus minus or a minus plus. Well, we need a minus here. So I'm going to say if I multiply these two together and these two together, it should give me this. So this, if I make this a minus and this a plus here, this will give me minus 2x. These two here will give me plus 1x. So if I add these two together, I get minus 1x. The number in the middle is a minus 1x, so that's fine. So all we got to do then is say if you multiply this by this and you get 0, it must mean that one of these must be 0. In other words, x minus 2 must be 0 or x plus 1 has to be 0. The only way you can get a 0 when you multiply two numbers is if one of the numbers is 0 or both of them. So let's see, we have x is equal to, just add 2 to both sides, so you get x equal to 2, subtract 1 from both sides, you get x is equal to minus 1. So the answer is x is equal to 2, 0 or x is equal to minus 1, 0. Remember, on the x-axis, y will be equal to 0. So we already have our y coordinates, so it's 2, 0 minus 1, 0. Next one then, we have part of the graph of the function g of x is shown in the diagram below. And we're given a couple of coordinates there, 4, 6 and 10, 1, local maximum and local minimum. Write down the two values of x for which g prime x is equal to 0, where g prime x is the derivative of g of x. So where g prime x is going to be 0 is going to be here and here. So in other words, g prime of x will give you the slope of any tangent on the curve. So it'll give you this, if you draw any tangent, you can find the slope. You can find the slope by putting the x value into your slope formula, into g prime x. Now we want the slope here. If you look at this tangent here and this tangent here, you'll see that they are horizontal lines, so the slopes will be 0. So we want our slopes to be 0 here and here. So in other words, it says write down the two values of x for which g prime x, the slope, is 0. So the two values of x are going to be 4 and 10. So x is equal to 4 and x is equal to 10. Is g prime 11 positive or negative? Give a reason for your answer. You may include work on the diagram. So it's going to be positive. 11 is here, and if you look at this part of the graph here, if you look at your tangent, that tangent there has a positive slope. It's pointing that way, it's sloping that way rather than that way. If it was sloping this way, it would have a negative slope. So it's going to be positive. Reason, well, you can say the slope of the tangent in the diagram at x is equal to 11 is positive. Or you could say the graph is increasing at x is equal to 11. So you can see here that the graph is increasing, so all of these slopes up along here, any slopes of any of the tangents up along there are going to have positive slopes. Here the graph is decreasing, so these will have negative slopes all the way down along here. All the slopes of the tangents along here will have negative slopes. Anyway, that's it for question 3. Okay, so let's have a look at the next question then. This is question 4. So f of x is equal to x cubed plus 2x squared minus 5. Find f prime x, where f prime x is the derivative of f of x. So if we have f of x is equal to x cubed plus 2x squared minus 5, then f prime x is then going to be equal to 3x squared. You just take the 3, bring it down here, and then reduce the power, reduce that by 1, so subtract 1 from that. So same here, we take this 2, we bring it down here, so it's 2 times 2, which is 4x, and then reduce this by 1, so that's really to the power of 1 there. And then here you just got a constant, so when you differentiate a constant you get 0. So our answer is 3x squared plus 4x. Now it says show that f prime 1 is equal to 7. So in other words, we've got to put 1 in here and 1 in here. So let's do that. So we've got f prime 1 is equal to 3 times 1 squared plus 4 times 1. So that's equal to, well, 1 squared here is just 1. Do the power first. 1 squared is 1. Then multiply by 3, you get 3. 4 times 1 is 4. 4 plus 3, 7. So that's it. Next one. Hence find the equation of a tangent to our function at x is equal to 1. Okay, so we've got to find the equation of a tangent. Now a tangent is a straight line, and the equation of a straight line is y minus y1 is equal to m into x minus x1. Now in order to complete this, we need two things to put into this equation. We need a point, so we need our x1, y1, and we also need a slope. Well, we've already worked out the slope at x is equal to 1. If you look back up here, we've got 7 here. We put in 1 into our equation, into our f prime. Remember f prime, if we differentiate a function we get a slope function. So we already put 1 in here and we got a slope of 7. So we have 7 as our slope. What we don't have is our 2 points here. Well, we actually have our x is equal to 1. So we have our x equal to 1 here. What we don't have is our y1. So the way we're going to find y1 is just simply to put 1 into our original equation. Now our original equation was, let's see, what was it? Y is equal to x cubed plus 2x minus 5. So we've got to work out what y is when x is 1. So I'm going to put 1 in here, 1 in here, and work that out. So we have 1 cubed, which is 1. 2 times 1, 2, minus 5. So 1 plus 2 is 3. 3 minus 5 minus 2. So our y is minus 2. So now I can substitute everything in. So we have y minus, well, it's minus 2 we've got to put in here. And then our m is our slope, so that was 7. Our x minus, well, our x is just 1. So I'm going to put that in here. So let's simplify this. We have y minus minus 2, so that's y plus 2. Let's multiply this out. 7 times x, 7x. Plus times minus minus, 7 times 1, 7. Now let's bring everything over to one side. So the equation of our line is 0 is equal to 7x. Let's say I'm going to bring this y over, so I'm going to subtract y from both sides, so it's minus y, and then I'm going to subtract 2 from both sides. So subtract 2 from this side, you get 0. Subtract 2 from this side, you get minus 9. Okay, so that's the equation of our tangent. Now let's look at part D. G of x is equal to, let's write that down, g of x is equal to x plus 11. We've got to find g of f of x. So this is a composite function type question. So remember f of x again, if I just write that down, f of x is x cubed plus 2x minus 5. That's what we were given at the very start of the question. So we want to get g of f of x. In other words, we want to take f of x and we want to put it into g. So we want to put it in here. So in other words, we get x cubed plus 2x minus 5. That's our f of x, and we've put that in here. Now we've got to add 11. So I'm going to add 11 here. So that's x cubed plus 2x. We have minus 5 plus 11. So go down 5, go up 11. So that's up 6. So our g of f of x is x cubed plus 2x plus 6. And that's it for question 4. Okay, next question is question number 5. So the graph of the function f of x in the domain minus 2 to 3, where x is real, is shown in the diagram on the right. The graph is symmetrical. Use the points shown in the graph to complete the table below. Okay, so we can see here we've got minus 2 is 0, so that's fine. Minus 1 up here. If we go up here and across, we can see that's going to be 4. We have 0 here, which is, we can see 6. We have x is equal to 1. So again, that's going to be 6. And then we have, let's see, we have 2, which we're given that as 4. And we have 3 here, which we can see is 0. So we just put in the y values there for each x value. So use the trapezoidal rule to estimate the area between the graph and the x-axis. Use the values of f of x from your table as your height. So the trapezoidal rule is the area is equal to h over 2 times. I'm going to do the abbreviated version, so it's just the first one plus the last one plus twice the sum of the rest. It's just my own kind of version of it, if you like. So h is the widths here. In other words, it's this distance here. So we can see it's 1 the whole way across. Each width here is 1. So there's only one h, so we can just put in one value. So the width here is from minus 2 to minus 1 is 1, from minus 1 to 0 is 1, from 0 to 1 is 1, and so on. So our h is 1, so that's 1 over 2. The first, what I mean by the first here is the first height. So we start here. That has a height of 0. It's minus 2, 0. So we put in a 0 there. Plus the last one then also has a height of 0. We can see here 0 plus 0 plus twice the other heights, if you like. So it's twice this height here. We're breaking it up into these trapeziums here, or trapezoids here. So let's see, this one here has a height of 4. That's the first one. Plus the second one has a height of 6. Third one has a height of 6 as well. And the second last one here has a height of 4. Remember, you've already included these two here, so you don't include those again. So we're just doing these ones after the 2, if you like. So we have to add 4, and that's really it. So the area is going to be a half of 2 times, well, 4 plus 6 is 10, plus 16, plus 20. So it's 2 times 20, and that's equal to a half of, well, 220 is 40, half. Well, I'll put that in there, 40. Half of 40 then is just 20, and that's, we're not given units, so I'll just put in units squared. So the area underneath the curve is approximately, I should say here, it's not actually equal to it, it's actually approximately equal to it. We're just estimating the area. It uses the word estimate here. Okay, so let's see, part B then. Express 16 as 32 rather in the form 2 to the power of k. Well, 16 is 2 to the power of 4. 2 times 2, 2 times 2 times 2 times 2 will give you 16. And then 32 is 2 to the power of 5. So in other words, 2 times 2 times 2 times 2 times 2 will give you 32. Hence or otherwise, so it's best to go with the hence. So we're going to do the hence, find the value of x for which 16 to the power of x is equal to 32. So they've given you a hint up here. We've already done 16 and 32. So 16 is 2 to the power of 4. So that's our 16, and that's the power of x. 32 is 2 to the power of 5. So by our laws of indices here, we can multiply these two powers. So that's just 2 to the power of 4x, and here we got 2 to the power of 5. So when you have 2 to the power of something is equal to 2 to the power of something, we can just equate those two powers. So in other words, 4x is equal to 5, or x is equal to 5 over 4. And that's it. That's all we had to do for that question. Okay, next question then is question 6. John invested €3,400 for 2 years. The interest rate was 4% for the first year, 5% for the second year. Find the amount of the investment at the end of year 2. So if we start with 3,400, it increased by 4% in year 1. So this is year 1. This is year 1. So we want to increase this by 4%. Two ways of doing this. You can multiply it by 4%, so 4 over 100, and then whatever you get, add it on. Or what you can do is do it in one step. You can just multiply it by 1, which will leave it as the 3,400, and then when you want to increase it by 4%, multiply it by 0.4%, which is 0.04. So this will increase this amount here by 4%. So if you do that, you'll get 3,563 euros. Now you want to take that in year 2, 3,563 euros, and you want to increase that by 5%. So you multiply it by 1, which will leave it as it is, and then you want to increase it by 5%, so 0.05, or 5 over 100. When you do that, you should get 3,712 euros 80 cents. Okay, so that's it for part A. Part B then. John's car was valued at 25,000 1 year ago. Today it has a value of 21,250 euros. Find a percentage decrease in the value of the car over the course of the year. So the first thing you would do is work out the decrease. So the decrease is just the original value, which is 25,000 euros, subtract the current value, which is 21,250 euros. So it has decreased by 3,750 euros. Now the percentage decrease is the decrease, which is 3,750, divided by the original value, which was 25,000 euros, and then you multiply it by 100 to convert it to a percentage. So when you do that, you should get 15%. Okay, next one then. Mary bought a painting 3 years ago. The value of the painting increased by 20% during each year for the last 3 years. The painting is now worth 8,640 euros. Find the value of the painting when Mary bought it. So the easiest way of doing this is to use the compound interest formula, which is in your tables. It's F is equal to P times 1 plus I to the power of T. So what do these letters mean? Well, F means the final value. So that's the value of the painting now, which is 8640. So 8640 is equal to the principal. That would be the original value. That's what we're actually trying to find. Find the value of the painting when Mary bought it. So that's P. and then we've got 1 plus the interest rate. Well, the interest rate is 20%, but if you notice from the tables, you don't put in 20, you put that in as a decimal. So in other words, 20 over 100 or 0.2, so it's plus 0.2. And then it is 20% over how many years? 3 years, so that's the time here. So you put that there. Now we've just got to work out what P is the original value of the painting when Mary bought it. So we just got to solve for P. So let's see what we get if we just simplify this a little bit. We've got 8,640 is equal to P times 1.2. So 1 plus 0.2 is just 1.2 to the power of 3. So I'm going to divide, since that's these two things here are multiplied, I'm going to divide by 1.2 to the power of 3. So it's 8640 divided by 1.2 to the power of 3, and that'll give me my principal here. And you'll find that when you work that out, you should get 5,000 euros. So that was the value of the painting when Mary bought it. So that's it for question 6. Okay, so next question then is question 7. So this is the first of the longer questions. Anna and Ross are saving to buy a house. Anna's gross annual salary is 50,800 euros and Ross's gross annual salary is 48,500 euros. The maximum that they can borrow is 4 times their gross combined salaries. What is the maximum amount of money that they can borrow? So we've got to add their two salaries. So we've got to add 50,800 and we've got to add, let's see, 48500. When you add those, you get 99,300 euros. So they can borrow 4 times their gross combined annual salary. So we've got to take 99,300 and multiply that by 4. So they can borrow 397,200. Okay, so that's part 1. They are interested in buying a house that costs 395,000 euros. In order to qualify for a mortgage, they must have a deposit of at least 12.5% of the price of the house. How much of a deposit do they need to have in order to qualify for a mortgage for this house? So we've got to get 395,000. That's the price of the house. And we have to get 12.5% of that. So you can do 0.125, which is just 12.5 over 100. So you can multiply by 12.5 over 100 or just multiply by the decimal 0.125. So they will need a deposit of 49375. So they'll need a deposit of 49,375 euros. Okay, next one. The builder expects to make a profit of 15% when this house is sold for 395,000 euros. Find the cost of building this house. Give your answer correct to the nearest euro. Okay, so what we would do here is take 115% as being the equivalent to the price of the house. It sold for 395,000 euros. So what we want to do is bring this down to 100%. So the first thing you would do is go to 1%. And then up to 100%. So this would be the cost of the house and this would be what it sold for. So how do you go from 115 down to 1? Well, you divide 115 by itself. Divide 115 by 115. So do exactly the same on this side. So it's 395,000 divided by 115. Now we want to go from 1 up to 100%. So how do you do that? Well, you multiply 1 by 100. So do exactly the same on this side. So it's 395,000 divided by, that should be 115. So that's 115 here, 115, and then we multiply by 100. So when you do all of that, you should get, let's see, the original cost of building the house would be 343,478 euros. Okay, so that's it for part 3. Let's have a look at part B. Mary earns 55,000 euros per year. She pays 10,100 euros tax on her income. She also pays 1,561 euros and 42 cents in USC. Find her net income and write it as a percentage of her gross income. give your second answer correct to 1 decimal place. Okay, so what we've got to do here is take 55,000 euros. That's what she earns. She pays tax of 10,100 euros, so we got to subtract that. She also pays 1,561 euros 42 cents in USC, so we've got to subtract that. So 1561.42, and that would give her net income, how much income she actually takes home. So when you do that, you get 43,338 euros and 58 cents. So that is her net income. So that's her net income. Now we've got to work that out as a percentage of her gross income. So you take the 43,338.58, you divide that by her gross income, which was 55,000 euros, and you multiply it by 100. So when you do that, you should get 78.797 and so on. We have to give this to 1 decimal place, so it is 78.8%. And that's it for part B. Let's have a look at part C. John earns 49,572 euros per year. The table on the right shows the rates at which USC is charged. Find how much USC John pays per annum. So he pays, let's see, on the first 12,012 euros, he pays 0.5%. On the next 10,908, he pays 2% and so on. So we're going to take 12,012 and we're going to multiply that by 0.5% or 0.005 or 0.5 over 100, whichever way you want to do it. But you should get 60.06 euros. So he does earn another 10,908 euros. If you add these two together, you still haven't reached 49,572. So we've got to take the 10,908 and we've got to multiply that by 2%. So we got to get 2% of that, or multiply it by 0.02 or 2 over 100. So when you do that, you should get 218 euros 16 cents. Now, if you add these two together, you should get 22,920. Now, the next amount is 47,000. So he isn't going to reach all of this. So what you've got to do is you've got to take what he earns, so the 49,572. You've got to add these two together and you'll get 22,920. So you will get 26,652. So that's what we're going to get 4% of, 26,652. So in other words, these three numbers here should add up to this number here. So you can check that this is the amount he earns. He earns 12,012 euros, then he earns another 10,908, and then he earns another 26,652. So we've got to get 4% of that, or multiply it by 0.04 or 4 over 100, and you should get 1,066 euros and 8 cents. So you've got to add all these up. So the total USC then is going to be equal to what you get when you add these three up. So that's 1,344 euros and 30 cents. So that's how much USC John pays per annum. We'll put the units in here as well. Okay, so that is it for that part of the question. Next part then. John gets a pay rise. He pays tax at 40% and USC at 4% on this extra income. His net salary increases by 1,400 euros per year after tax and USC are deducted. Find his gross pay. Well, this 1,400 euros will be equivalent to, if you like, 56%, because the 40% and the 4%, they're gone on tax and USC on the extra income, so that's 44%. So the remaining 56% then must be represented by his net salary increase. That's equivalent to 56%. We've got to find his gross pay. So this is what he actually takes home in extra income. So we got to find his gross pay rise. So again, let's go down to 1% and up to 100%. So how do you go from 56 to 1? You divide by 56. So take 1400, divide by 56. How do you go from 1 up to 100? Well, multiply by 100. So it's 1400 over 56, multiply by 100, and that should give you 2,500 euros. That's his gross pay rise. Okay, and that's it for question 7. Okay, next question then is question 8. The diagram below shows the first 3 patterns of a sequence of patterns of dots and lines. So we have pattern 1, 2, and 3. Draw pattern 4, which I have done here, and there are 25 dots here. Okay, complete the table below showing the number of dots in each pattern. So I counted the dots up as far as here. We have pattern 4, so I got 25 and 13. How did I work out 41? Well, if I write out, let's say 1, 5, 13, and 25, these are the ones that I have. 1, 5, 13, and 25. We find that it's a quadratic pattern. In other words, if you look at the difference between 5 and 1, you get plus 4, 13 and 5 plus 8, 25 and 13 plus 12. If you do the second difference, the difference between 4 and 8 is plus 4. The difference between 8 and 12 is also plus 4. So we got to work out the next one here. We've got to work out this 41. So what you would do is start from the bottom. So we'll put a plus 4 here. So we need to add plus 4 to plus 12. So that means we've got plus 16 here. And then add 16 to 25. And that's where we got the 41 from. Okay, so that's the table filled out. The next part then is, let's see, part 3 here. We have Tn is the number of dots in pattern n of the sequence, where n is a natural number. Tn is given by 2n squared plus bn plus c, where b and c are integers. Let's see, t1 is equal to 1, t2 is equal to 5. Show that this means b plus c is equal to minus 1. Okay, so if we take the first one here, we know that t1 is equal to 1. So that means if we say we have tn is equal to 2n squared plus bn plus c. Well, we know t1 is 1, so we put that in here. And then we've got 2 times, remember n is this number here. So that's 1 squared plus b times n again, which is 1 plus c. So that'll leave me with 1 is equal to, again, square the 1 first. So 1 squared is 1. Multiply our answer by 2, so that's 2. Plus b times 1 is b plus c. And then finally just subtract 2 from both sides. So if I subtract 2 from the left hand side, I'll get minus 1. Subtract 2 here, I'll get 0. And I'm just left with b plus c. So that's it done. That's the first one done here. Second one then, we're told that t2 is equal to 5. And presumably this will give us the second one. So again, t2 is equal to 5. So using the same formula again, we know that 5 is equal to 2 times, this time n is this number here, which is 2. So we square that, plus b times 2 plus c. So again, we've got 5 is equal to, square this first, so 2 2s are 4. Multiply our answer by this 2 here. So that's 8 plus 2b plus c. And then finally subtract 8 from both sides. So subtract 8 from 5, you'll get minus 3. You go up 5, go down 8. You're at minus 3. And it'll just disappear here on the right hand side, or we'll get 0. So we end up with 2b plus c. So that's what we were asked to find. 2b plus c is equal to minus 3. Okay, so we've got to solve these now. So let's write them down. We've got b plus c is equal to minus 1. And we've got 2b plus c is equal to minus 3. I'm going to call this equation 1, this equation 2. I'm going to take equation 1 and I'm going to multiply it by minus 1. So if I multiply all these terms by minus 1, I'll get minus b, minus c, and then minus minus is plus, so plus 1. Now if you notice why I did that, I've got a plus and a minus c here now, which will cancel if we add the two equations. So if I take 2b minus 1b, that'll leave me with b, plus c minus c will give me 0, which is what I wanted. And on this side then I end up with minus 3 plus 1. So go down 3, up 1. That leaves me with b is equal to minus 2. So let's take one of the equations then. Let's take the first one, b plus c is equal to minus 1. Doesn't matter which one you take, it should work out for both of them. So we're going to replace b with minus 2. And we end up with c is equal to, I'm going to add 2 to this side, add 2 to this side. So I end up with c is equal to 1. So b is equal to minus 2 and c is equal to 1. That's all we had to find the values of b and c. So we can put them in here, minus 2 and 1. Okay, next question then. The total distance Dan has driven in kilometers is shown on the dashboard of his car. The table below shows the readings on the dashboard at the start of each week for 4 weeks, where p and q are natural numbers. Dan drives the same total distance each week, hence find the values of p and the value of p and the value of q. So if we take the highest number here, which is 104,500, let's subtract the 100,000. So if we subtract these numbers, we get 4,500. So we know that the difference between this number and this number here is 4,500 kilometers. So we need to divide that up into 3 parts. So 4,500, divide that by 3, that'll give us 1,500 kilometers. So in other words, we need to add 1,500 kilometers to this to get P, then add 1,500 kilometers to this one to get Q, and if you add 1,500 kilometers to this one, you should get this number here. So it's a good check at the end. So let's do that. Well, we have 100,000 plus 1,500. That just gives us 101500. So that's going to be P. So P is 101500 kilometers. So 101,500 kilometers. Now we take 101500 and we add another 1,500. And that'll give us, let's see, 103,000 kilometers. So 103,000 kilometers is Q. So you can check it by taking 100. So this is just a check. You aren't asked to do this, but you could check it just to see if you're right. 103,000. And what we want to do is add 1,500. So let's just try that. So this gives us 005,401. And it is 104,500. So that seems to work. Okay, so let's try the next one then. So we have the sequence of colors and timings of a set of traffic lights is shown in the table below. The sequence repeats as the lights change during the day. So we have green stays on for 13 seconds, amber stays on for 2 seconds, red for 20 seconds. Dan is walking along the road and notices the lights change from amber to red. He continues to look at the lights. So the clock is really starting as he looks at the lights and they've just turned red. How long will it be from the time the light first changes to red until Dan sees it change to amber for the 3rd time? So we're going to start with red, and that's going to be on for 20 seconds. Then it's going to go to green. That's going to be on for 13 seconds. And then finally amber, and that's going to be on for 2 seconds. So that's going to be the sequence then. So we can go red. It says for the 3rd time that he sees amber. So it's red, green, and amber again. So that's 20, 13, and 2 seconds. Let's go again. Red, green, and amber for the 3rd time. So red is 20, green is 13 seconds. But at that point, it will just turn to amber, so we need to stop here. So we need to add these ones. So when you add all of those up, you get 103 seconds. That's when it's just about to turn to amber for the 3rd time, when he just sees it changing to amber for the 3rd time. Okay, and the next one then, what color will the lights be exactly 25 minutes from the time Dan notices the first change from amber to red? Show any calculations you make to arrive at the answer. Okay, so we need to look at 25 minutes, and we just need to change that to seconds. So I'm going to multiply it by 60 because there are 60 seconds in a minute. So that's 1,500 seconds. So if you notice that each cycle here takes 20 plus 13 plus 2, so that is 35 seconds. So he's looked at it, it's just turned red, so he's starting here. So it's going to go 35 seconds, another 35 seconds, another 35, and so on. So we've got to look at how many 35 seconds there are in 1500 seconds. So we take 1500, I'm going to divide that by 35, and we'll get 42.87 and 857 and so on. So we're going to see 42 cycles of red, green and amber. So what is remaining then? So we take 42 and multiply it by 35. We get 1470 seconds. So that leaves us with 1500 seconds minus 1470. So there are 30 seconds left. So after the last cycle, after it turns to amber for the last time, there's 30 seconds left. So what will happen? It will turn red for 20 seconds and then it will turn green for another 10 seconds. So there's your 30 seconds and then an extra 3 seconds on green. So it will be green during those 30 seconds. So let's just write that down. So therefore the lights will be green, and that's it for that question. Okay, so let's look at the next question then. Paul O'Donovan and Fintan McCarthy are Irish rowers. They won a gold medal in the 2020 Olympic Games. The course they raced on was 2,000 metres in length. The following table shows their time since the start of the race as they passed various markers at set distances along the course. Their time is in seconds and the distances are measured in meters. So the first thing we have to do is just draw that graph. So I've done that already. So at 0, we're looking at 0 distance, at 0 time. At 500 meters, we're looking at 78.6. So I've done that here and here and here and so on. And I've connected them up. Use your graph to answer part A2 and part A3. Show your work clearly on the graph. Estimate how much time had passed when they had travelled 750 meters from the start. So 750 meters would be here. So we need to go up and across here and read this off. But you would be expected in the exam to actually draw that in on your graph. So you would be expected with a ruler. I can't use a ruler here, but to draw a line up along here and then across here. So I am looking at about 140 seconds, I'm going to say. So it's going to vary from person to person depending on how they drew the graph, but I'm going to say 140 seconds. How far did they travel during minute 5 of the race? That is between 240 and 300 seconds. So 240 would be about here. So again, you'd need to come over, use a ruler again and come down along here. And the second time was 300 seconds. So 300 seconds is here. So again, come across here and down. So you're looking at this distance here. So the distances that I'm going to say are, I'm going to say this is about 1700 meters and I'm going to say this is 1300 meters here. So you just need to subtract those. So it is 1700 meters. Then we've got to subtract 1300 meters. That will give us, let's see, that's 400 meters. And again, that's going to vary slightly between one person and another. So Paul and Fintan finished the race in a time of 366.43 seconds. Find their average speed. So give your answer in meters per second, correct your 2 decimal places. So this is just a speed, distance, time type question. So you might be familiar with Dad's silly triangle. So this is Dad's silly triangle. Multiply these two here. So distance is speed times time. Speed is distance divided by time. And time is distance divided by speed. So we have to find speed. So speed is equal to distance over time. So in our case, the distance is let's see, what was it, 2000, I think 2000 meters. We got to divide that by the time. They're telling us that the time was 366.43 seconds. So you've just got to do that on your calculator. You get 5.45806 and so on. And we've got to give this to 2 decimal places. So we're going to stop here. The number after the 5 is a 5, 6, 7, 8 or 9. So you got to round that 5 up. So it's 5.46. And the units here are meters per second. Okay, next one then. Paul and Finton also won gold at the 2022 World Championships over the same distance, 2,000 meters. In that race, they rode at an average speed of 5.31 meters per second. How long did it take them to finish the race? So we got to give our answer in minutes and seconds, correct to the nearest second. So again, we can use that silly triangle, but this time we need to work out how long did it take. So we need to work out time. So in this case, time is distance divided by speed. So again, the distance is 2,000 meters and the speed this time is 5.31 meters per second. Okay, so when you divide 2,000 by 5.31, you should get 376.6478 and so on, and that is in seconds. So what we need to do is convert this to minutes. So what you do is divide this by 60. When you divide that by 60, you get 6.27746 and so on, and that's in minutes. Now they want their answer in minutes and seconds, and the seconds need to be correct to the nearest second. So it's going to be 6 minutes anyway. And then what you do is just take this part of the decimal here, convert that to seconds. So it's 0.27746 of a minute. So multiply 0.27746 by 60. And that'll give you, let's see, 16.64 and so on of a second. We need it to the nearest second, so that's going to be, let's see, 6 minutes and 17 seconds. Okay, so let's look at the next part of the question. 2 different rowers, A and B, compete in a race. As they row, their bodies burn calories. They burn calories in the ratio A is to B, and that's 10 is to 11. During the race, they burn a total of 53.55 calories between them. Find out how many calories each rower burned during the race. So the ratio that we've got is 10 is to 11, and that's A is to B. Now the way you work ratios here is you would add these two, so 10 and 11 will give us 21. So in other words, we need 10 out of 21 of the total number of calories burnt, which was 53.55, and we need 11 out of 21 times 53.55. So in both cases then you will get 25.5 calories and 28.05. So rower A burnt 25.5 calories and rower B burnt 28.05 calories. And that's it for part C1. Part C2 then. The 2 rowers A and B compete in a different race. In this race they burn calories in the ratio A is to B, and that's 1 is to or, where or is real and is a constant. At the end of the race they have burned a total of 57.5 calories between them. Rower A has burned 25 calories. Find the value of or in this ratio. Okay, so again we've got A is to B and we have 1 is to or. So again we do the same thing again, add 1 and or and you get 1 plus or. So we need 1 divided by the total, in this case is 1 plus or, multiply that by the total calories burnt between them, which was 57.5, and remember this is a 1 over 1 plus or will give us A. So what we're going to do is let that equal to the number of calories that rower A burnt, which was 25. So we have an equation here. All we've got to do is work out what or is. So let's do that. So let's see, the first thing I'm going to do is 1 over 1 plus or is equal to 25 divided by 57.5. Because the 57.5 is multiplied, so I'm just going to divide by 57.5. Let's see, next thing I'm going to do, I might just simplify this fraction on the right. So if you just stick it into your calculator, it should simplify it for you. So you got 1 over 1 plus r is equal to 10 over 23. Okay, I'm just going to come up here now. So you got a fraction equal to a fraction, so I'm just going to cross multiply. So I'm going to multiply 1 plus r by 10. So that's 10 times 1 plus r. And that's equal to 23 times 1, which is just 23. So that'll give me, let's see, I'm going to divide by 10. 1 plus r is equal to 23 divided by 10 is 2.3. And then I'm going to subtract 1 from both sides. So that'll finally give me r is equal to 1.3. I think that's all we had to do. Find the value of r in the ratio. So r is just 1.3. That's really it for this question. Okay, so last question then. This is question 10. Functions can be used to model wind speed as it changes over time. So we have the function here f of x, which is x cubed minus 12x squared plus 36x plus 10. X is between 0 and 8 and x is real. It was used to model wind speed on a certain night at a particular location over an 8-hour period between midnight and 8 a.m. The wind speed was measured in kilometers per hour and x is the time in hours after midnight. So complete the table to show the values of f of x for the given values of x. Now I've completed that table here. It's really just a case of putting each x value in here, here and here. These are the x values along here, 0, 1, 2, 3, 4, 5 up to 8. So I've done one example here. I've taken x is equal to 3. So I put 3 in here, here and here. And it's just calculator work after that. 3 cubed is 27. 3 squared is 9. Multiply by 12. Make sure you square this first. And then 3 36, 108 plus 10 gives you 37. So that's where this 37 comes from here. You do the same with all of these. Then it says to draw the graph. So I've done that here as well. So again, you just read off the x-axis is 0, y-axis 10. So 0 on the x-axis, 10 on the y-axis. Here we've got 1, 35. So 1 on the x-axis and then 35 on the y-axis here and so on. And you get this cubic curve here. So next question then, it just says the diagram below shows the graph of a model for the wind speed in kilometers per hour on a different night at the same location over the 8-hour period between midnight and 8 o'clock. So this is this cubic curve here again. And the questions then that we have to answer are 1 and 2 here. So what was the wind speed at 3 a.m.? Give your answer in kilometers per hour. So I've done that here, 3 a.m. here. You just need to draw a line up along here, go across here, and I got 45. Now you will be given a certain tolerance around your readings. Different people might read off slightly different readings here on the y-axis, so you will be allowed a certain tolerance. But I'm saying 45 kilometers per hour. That's what I got here. On the Beaufort wind scale, winds between 75 kilometers per hour and 88 kilometers per hour are referred to as strong gale force winds. Use the graph to complete the sentence below. On that night, strong gale force winds were blowing between what time and what time? So we need to read off 75 and 88 kilometers per hour. Well, 75 is here, 88 is up here. The maximum actually in this particular graph is 85. So we just need to look at this part of the graph here. So that's between 75 and 88. So you would draw a line across and then 2 lines down. And I got between 4 and 6. So between 4 a.m. and 6 a.m. Okay, next question then. On a third night, the quadratic function g of x, which is minus x squared plus 8x plus 9, x is between 0 and 8, x is real, was used to model the wind speed in kilometers per hour at the same location over the 8-hour period between midnight and 8 a.m. Solve the quadratic equation to find the 2 times when the wind speed was exactly 24 kilometers per hour according to g of x. So we need the wind speed to be 24 kilometers per hour. In other words, minus x squared plus 8x plus 9 must be equal to 24 because g of x is the wind speed. So this is the wind speed here. So we want the wind speed to be 24 kilometers per hour. So we just got to solve this. So let's see, let's bring the 24 over anyway. So we've got minus x squared plus 8x, and then we've got minus 15 is equal to 0. So I've just subtracted 24, subtracted 24. Okay, so now we have a quadratic trinomial which we need to solve. I don't like this minus at the start here, so what I'm going to do is multiply everything by minus 1. So I multiply this by minus 1, I'll get x squared. Multiply this by minus 1, I'll get minus 8x. Multiply this by minus 1, I will get plus 15, and that's equal to 0. So we just have a standard quadratic trinomial to solve here. So you can do that a couple of different ways. You can factorize it, which is what I'm going to do, or you can use the quadratic formula. This is probably the easiest way of doing it. We have a 15 out here at the end, so if we look at 15, we've got 1 times 15 and 3 times 5. I need an 8 in the middle, so it's probably going to be 3 times 5. So 3 times 5, 5 and 3 will give me 8. Now I need to multiply 3 by 5 to give me a plus. So that means I'm going to have minus, minus, or plus, plus. This is a minus, so it's going to be minus, minus. Okay, so let's see. We have x minus 3 equal to 0, or x minus 5 equal to 0. If you multiply two things together and your answer is 0, one of those must be 0, or both of them are equal to 0. So if x minus 3 is equal to 0, that means x is equal to 3, so just add 3 to both sides. Let's see, if x minus 5 is equal to 0, that will give me x is equal to plus 5, so add 5 to both sides. So in this case, the answer is going to be between 3 a.m. and 5 a.m. And that's it for part 1. It says use differentiation to find the time when the wind speed was at its maximum and find this maximum speed according to g of x. So to find a maximum or a minimum, what we need to do is differentiate the function. So the function was, I think it was called g of x, and it was minus x squared, and then plus 8x plus 9, plus 8x plus 9. So we need to differentiate this in order to find a minimum or a maximum. So maximum in this particular case. So take the 2, bring it down, so you get minus 2. Write down the x, reduce the 2 by 1, so that's power 1 there. Plus, there's a 1 power here, so bring that down, multiply it by the 8, you'll get 8. And then x to the power of 1 less than 1, which is 0. So x to the power of 0 is just 1. So it's just 8 times 1, which is 8. Differentiate the 9, you get 0. So we want a maximum, or a minimum, or maximum in this case. So it's going to be minus 2x plus 8. We need to let that equal to 0 in order to find a minimum or a maximum. So it's going to be a maximum in this case. So let's just solve this. Minus 2x is equal to minus 8. So I just subtracted 8 from both sides. And then divide by minus 2. Divide minus by minus, you get plus. 8 divided by 2 will give us 4. So that's the time. So it's going to be 4 a.m. was when the wind speed was at its maximum. And to find that particular maximum, then we just need to put that 4 back into the original equation, back into this equation here. So let's do that. We want g of 4. So that's going to be equal to minus 4, which we need to square, and then plus 8 times 4, and then add 9. So it's going to be minus, well, 4 squared is 16. We're not squaring the minus. Plus 4 eighths, 32. Plus 9, minus 16 plus 32 is plus 16, and then plus 16 plus 9 is plus 25, and that was our y, so that is kilometers per hour. So there are two answers. So the first answer was what we got up here. We got x is equal to 4, so the time was 4 a.m. and the actual wind speed at 4 a.m. was 25 kilometers per hour. Don't forget to put the units in. If you leave out units, sometimes they'll take marks off. And that is it for this question and this paper.